everyone. In today's video, we are going to learn about the important result in a number theory that is called as a Chinese Remainder Theorem, or generally call it as a CRT in short. Have you ever thought, if we have the multiple linear congruence equations of this form, how to find one single value of x that satisfies all the equation at once? And importantly, when it is possible, how to answer that one? So in this case, we are going to learn the Chinese remainder theorem that solves this type of a system of equation. In this case, first condition we need to check whether all the modulos m1, m2, m are pairwise relatively prime numbers, means GCD of every pair of modulo is 1. If yes, then the solution exists that is corresponding to the modulo m. Now what is m? That is the product of all the modulos. And the solution is further calculated by this form. It might sound complicated, but actually it contains only 5 steps. Let's understand this within an example. Here we have considered the system. Our job is to find a single value of x that satisfies all these 3 congruences. In order to apply the Chinese remainder theorem, first step is we need to check whether m1, m2 up to all mi's are pairwise relatively prime numbers. So compare this with this. According to this, we have small m1 is equal to 3, m2 is 5, m3 is 7. Means we are collecting all the modulos and that is represented by small m. Now, is the GCD of m1, m2 is 1. What is the GCD of m1, m2? What is the common between these two one? GCD is 1. GCD of m2, m3, that is 5 and 7, is also 1. And what is the GCD of m1, m3? 3 and 7, again 1. Since the pairwise are coprime numbers, we can apply the Chinese remainder theorem. Here we have taken the first step. We will compare the given system with the original one. Find small m2, small m3. Now we can also extract the value of ai's. The value of a1 in this case is 2. Basically, they are the remainders. In case of second, 3. In case of third, it is 2. So these are the given entry in the question, small m1, small ai's. Now the first step is we will calculate small m. Small m is product of all the modulus, that is 3 into 5 into 7. This is equal to 105. After that we are going to calculate capital M case, that is for each equation we will get a different capital M. That is capital M1, capital M2, capital M3. This is calculated by small m by corresponding modulo. So it means capital M1 is equal to m by small m1. So this is equal to 35. Capital M2 is small m by m2. This is equal to 21. Capital M3 is small m by m3 is equal to 15. So these are the 3 steps we need to do. After that we have the fourth step where we need to calculate y1, y2 up to yn. So here we have the 3 equations. We need to calculate 3 yi's, that is y1, y2, y3. For that we will use this condition. As per this condition, first equation is this, where capital M1 is 35, small m1 is 3. Here we need to find the value of y1, but before finding the value of y1, first simplify this largest number if you can. Basically we are working with the modulo, and in modulo we are dealing with the remainders. When 35 is divided by 3, what is the remainder in this case? That is 2. So instead of 35 into y1, we can write 2 into y1. That is congruent to 1 mod 3. Now by hit and trial, find the value of y1. For what value of y1 when multiplied by 2 divided by 3, the remainder is 1. Check it. For y1 is equal to 0, whether we are getting remainder 1? No, because 2 into 0 is 0. For y1 is equal to 1. 2 into 1, 2. That remainder cannot be 1. y1 is equal to 2. 2 into 2, 4. 4 when divided by 3, remainder is 1. It means the value of y1 is 2. Similarly, calculate the value of y2 with the help of this equation. Capital M2 is 21. y2 congruent to 1 mod small m2, that is 5. Think, can we further simplify this equation? Yes. 21 when divided by 5, remainder is 1. So instead of writing this, we can write y2 is congruent to 1 mod 5. When we are simplifying this one, sometimes we are getting a direct value of variable, and in this case the variable value is 1. Because 1 cannot divide by 5 and its remainder is 1 itself. Similarly, for the third case, we can have this equation. Capital M3 is 15, y3 congruent to 1 mod 7. 15 when divided by 7, remainder is 1. So y3 is congruent to 1 mod 7. So in short, direct we have the value of y3, that is equal to 1. Now we have small m1, a1, capital M1, y1, as well as we have small m, that is equal to 105. In the last step, we just need to calculate x, and that is calculated by this form, that is equal to a1 capital M1 y1 plus a2 capital M2 y2 plus a3 capital M3 y3. This is equal to this, where a1 is equal to 2, capital M1 is 35 into 2. Product this one plus product this one plus product this one. This is equal to 233. After that, we just need to calculate what is the remainder when this number is divided by small m. It means we need to convert this equality in form of congruency. So x is congruent to 233 mod m, and the value of m is 105. Now this number is greater than 105, so we can further simplify this and find the remainder in this case, that is equal to 23. How? Because 105 into 2, that is equal to 210, and when we subtract from 333, we have 23. So remainder in this case is 23. Now check it whether 23 is the solution of this system or not. X when divided by 3 is the remainder is 2. Means when 23 is divided by 3, remainder is 2? Yes. 23 when divided by 5, remainder is 3. 23 when divided by 7, remainder is 2. It means one of the solution is x is equal to 23. And the rest of the solution is always written in form of plus divisor into some constant, that is k as an integer. So this is how we need to apply the Chinese remainder theorem. We have 5 steps in this case. First, from the given equation, extract the values. That is the first step. Second step, check it whether the GCD is 1 or not, and then calculate small m. Third step, calculate corresponding value of capital M and then find its inverse. That is the fourth step. At last, calculate the value of x, then take the modulo with respect to m.